this lecture series, uh, a video second of the topic theory of equation, and which is the part of BSc first year semester 1 paper Algebra and Trigonometry. So earlier what we have studied the type of equation, linear equation, quadratic equation, cubic equation, biquadratic equation, complete equation, root of equation. Previously we have discussed all these things. Now we are going to discuss the intermediate value property. So what basically intermediate value property means, we have to look after, and we will illustrate it later. So intermediate value property. Consider a polynomial f of x of degree n, and let a b belongs to capital R. And if f of a and f of b have a different signs, then the equation f of x equal to 0 has at least one real root between a and b. What this actually means, if f of x is a degree of f of x is a polynomial equation of degree n, okay, a and b are the real numbers. Now when we put the values of a and b in the equation f of x, in place of x, then is x replaced by a, then we get f of a. When we replace x by b, then we get f of b. Now what is the condition? If f of a and f of b have different sign, that means if f of a is positive and f of b is negative, or if f of a is negative and f of b is positive, then the equation f of x equal to 0 has at least one real root in between a and b. So what it basically means, in between that a and b there exists one other root. Suppose that root is c, and there is a real root. Means what means, if that real root which is in between a and b we put in this equation, that is f of x equal to 0, then we get the f of c equal to 0. Suppose c is a root, then we get c is f of c is equal to 0. So that's how intermediate value property works. So once again we repeat, if you have consider a polynomial f of x of degree n, and let a and b belongs to R. If f of a and f of b have different sign, then the equation f of x equal to 0 had at least one root between the a and b. Now if there is no real x which makes f of x equal to 0, then f of x is either positive or negative for all x belongs to R. That is very simple. Okay. Now um, we come on to the next statement of the theorem, which is very important. Okay, it is about the complex number. As we all know, what are complex number. And the statement is, in an equation with real coefficient, if complex root occurs, then they occur in pairs. That means, if in an equation if complex root occur, then they occur as a, if a plus ib is one root, then a minus ib is another root. If any equation, if we get 2 plus 2 plus 3i as a complex number root, then 2 minus 3i is also another root. That's how the that's how it works, that complex root occur in pair. Singly complex root uh, नहीं आता है या नहीं मिलता है. So this statement is true only if equation coefficient of the equation are real. Remember this. Similarly, the condition is true for the third root also. If a plus under root b is a root of the equation f of x equal to 0, then with integral coefficient, then a minus root b is also a root of the equation where a and b are real and b is positive. So once again repeat this. If a plus root b, that is third root, is a root of the equation f of x equal to 0 with integral coefficient, that means the coefficients are integers, then a minus under root b is also a root of the same equation where a and b are the real and b is a positive number.